So we'll try to wrap up part C and D of problem number 2 from 2003 Form B of the AB exam here. And the situation that's described is there's a tank that holds heating oil, and it initially starts with 125 gallons of heating oil at time t equals 0. Oil is pumped into the tank at this rate over the course of the time frame from 0 to 12 hours, and heating oil leaves the tank at this rate, both rates measured in gallons per hour, from 0 to 12 hours. Part C wants us to figure out how many gallons of heating oil are in the tank at time t equals 12 hours. So a good starting point here would be how much heating oil you start with at the beginning of the time frame. We start with 125 gallons of heating oil in the tank at t equals 0. We need to add on how much heating oil enters the tank over the course of this time frame and subtract off how much heating oil leaves the tank over the course of this time frame. So back in part A in the previous video, we said that this integral right here, integrating the rate at which heating oil enters the tank from the t-value of 0 to the t-value of 12 gives you the total amount of heating oil that enters the tank over the course of this time frame. If we want to subtract off the total amount of heating oil that leaves the tank over the course of this time frame, we're going to integrate the rate at which heating oil leaves from 0 to 12. And if we can find the value of this expression right here, we're going to have the answer to part C. The calculator is definitely in play for this problem, and you would definitely want to do this definite integral and evaluate this on your calculator. I'm going to simplify this a little bit before we do, though. I don't want to do two separate integrals on the calculator. I want to do one integral. And so typically when we do integrals by hand, when we do definite integrals, antiderivatives by hand, we maybe start with a single definite integral and break it up into two separate definite integrals. In this case, I'm going to kind of do the opposite. I'm going to break this up into the difference of two separate definite integrals and rewrite it as the sum of a single definite integral from 0 to 12. So the function within my single definite integral is going to be h of t minus r of t. We'll just make using the calculator a little bit easier if we have it written in this form. We only have to evaluate one integral rather than two separate integrals. Now, on my calculator, left over from parts A and B, I have the graph of h of t, that's this decreasing function, and the graph of r of t, that's this sine wave here. I have those graphed already. I don't have h of t minus r of t graphed. I can take a minute to graph this function within the integral and do the integral from the graph screen, but I have this set up on my home screen already to integrate there. And so this function integrator option is actually found in the math menu. The second option from the bottom, if you hit the math menu, is a function integrator tool. And I already have that set up, and I've already typed in h of t minus r of t. After I type the function that I want to integrate in, I need to give the calculator the variable of integration. Now I realize on our page here the variable of integration is t, but really what I typed into the calculator here was x. So my variable of integration on the calculator is x. You give the calculator another comma, you give it the lower limit of integration, which is 0, you give it another comma, your upper limit of integration is 12. Close the initial parenthesis that the function integrator feature gave to you, and the calculator will think for a minute and give you the answer. So the value of this integral is negative 2.974, and we're going to have to round this to three digits in a minute here. But before I round this, this is the change in the amount of heating oil in the tank from t equals 0 to t equals 12. The actual amount is going to be 125 plus that negative value. So the amount of heating oil has actually gone down slightly over the course of this 12-hour stretch. And if I just take 125 plus that, or that answer plus 125, this is how much heating oil we have in the tank at the end of 12 hours. So 122.02, and then if I truncate, I'd put a 5 next. If I round, I'd be going with a 6 next. I typically go with rounding as opposed to truncating. We have this many gallons of heating oil in the tank at the end of the 12-hour time frame. If you left this as 122, if you left it as 122.02, unfortunately, because you didn't carry 3 digits of accuracy, you're going to miss a point for that issue. So our answer for part C is that many gallons. Part D is going to be based off of what we've done in part C to a certain extent. It says at what time from 0 to 12 is the volume of heating oil in the tank the least. show the analysis that leads to your conclusion. So we're basically looking for the absolute minimum amount of heating oil in the tank between these two times. Now our candidates here are always endpoints of closed intervals, and we're definitely dealing with the closed intervals. 0 and 12 are values that we're going to have to analyze. And if we want to know when the heating oil in the tank is the least, we're also going to need to figure out the end of any time frames where the rate at which water leaves is above the rate at which, and I think I said water, I meant to say heating oil, the rate at which heating oil leaves is above the rate at which it enters. So if I go back to my graph screen here, this is the rate at which heating oil enters. So from 0 to whatever this time is, we have more heating oil entering the tank than leaving it because the rate at which it enters is above the rate at which it leaves. So this t value right here, or this x value from my graph, that's not a candidate for the least amount. That's a candidate for the maximum amount. Now this t value right here, this is the end of a time frame at which heating oil was leaving the tank. It's leaving at this rate at a larger value than it was entering. So the other value that I'm going to have to consider is this t value right here. So if we find that by using the intersect feature of the calculator, so first curve, second curve, and now is when I want to kind of scroll over and make sure I get close to the second intersection that we see on the screen here. So my other t value is going to be 11.31847. I'm going to take all of those digits of accuracy for the time being. Our eventual answer, we're going to round off to 3 digits of accuracy, but I don't want to round off this value right now and then lose accuracy later on because I rounded off an intermediate calculation. So we're going to have to figure out how much oil is in the tank at t equals 0. Well, we know that. We know the amount of oil in the tank at t equals 0 is 125 gallons. We're going to have to figure out how much heating oil is in the tank at t equals 12. Well, we know that. We found that in part B. That answer from part B was about 122 gallons. We're also going to have to figure out how much heating oil is in the tank at this new value, this 11.3 value. And to figure out how much heating oil is in the tank after 11.3 hours, we're going to do what we did in part B, and that's take the starting amount, which is 125 gallons of heating oil, plus how much the level of heating oil in the tank has changed from 0 to 11.3 hours. And the function that we're going to have here is the same function as before. It's going to be h of t minus r of t. So I'm using the same formula here as we used in part B to figure out how much heating oil was in the tank at the end of this 12-hour stretch. On my calculator, the nice thing about doing an integral from the home screen is if we already have done an integral from the home screen and we want to do a new integral, just use the second enter feature or the entry feature to make previous entries reappear. And I want to do the exact same integral, but I don't want my upper limit of integration to be 12 here. I want it to be not just 11.3. I don't want to round off this number and lose any accuracy, so I'm going to carry all the digits of accuracy as I wrote down over here a minute ago as I get the calculator to give me this value. So from 0 to 11.3, the amount of heating oil in the tank changes by this amount. So the amount in the tank after 11.3 hours is going to be that value plus the amount that we had in the tank initially, which gives us about 120.738. So this is the one that I'm going to take to 3 digits of accuracy. So let's just make sure that we answer this accordingly here. At what time from 0 to 12 is the volume of heating oil in the tank the least? Well, since this is the smallest number of gallons we see at any of our candidates, the time when the amount of oil in the tank is the least is at this time. I could, truncate this to the 3rd digit and write it as 11.318, but as long as I've taken more than 3 digits of accuracy in my answer for the purposes of free response questions on the AP exam, that will be good enough. You want at least 3, you're allowed to have more than 3.